Again a video for networking. In today's video, we are going to see about Open System Interconnection Model, simply known as OSI model. And you can see a picture of a OSI network stack, a client to server. We have a switches in between, and HTTP, TCP/UDP, IP link means a data link layer and a physical layer. Then frames converted to packets, packets into segment, segment into message. We'll clearly see how it works. We'll see this picture at the last, and first I'll start with application layer. Application layer, where the connection originates. This application layer is like a user interface, like a browser. Okay. If we give a URL and we give enter, that all starts in this application layer. Just think it as a browser. Okay. And this layer allows us to communicate over internet when the connection is established, like HTTP telnet. We have already spoken more about HTTP and HTTP request and response. Next comes our transport layer. Transport layer, where data encapsulation begins. When data is arrived from application layer to transport layer, the process of encapsulation is done. And the port number identifies the port. Port is nothing but it is a dedicated location for a memory for sending and receiving data. This all occurs in the transport layer, and the important part of transport layer is TCP/UDP. We'll see about TCP now. TCP is a connection-oriented protocol. And now, what does a TCP segmentation mean? A TCP divides the data from the application layer into segments and adds header to each segment. Simply, it receives data from the application layer and then adds a header to the HTTP segment or the data segment. Okay, now a question will arise. What does that segment header will contain? Segment header contains sending and receiving ports, segment ordering information, and data filled with checksum. Now, you may already heard about checksum. Okay. In this, both the host will have a checksum to determine the data transfer is without error. This checksum is basically like something encrypted, or it just checks for any error has occurred in the way while traveling. If there is a missing or a corrupted data packet, it will receive a retransmission using a NAC message to sender. This NAC you will see in the three-way handshaking, and now we will see how does this TCP connection is established. A TCP segment called sync is sent to TCP on receiving host. This SYN is like acronym for synchronization, and ACK is for acknowledgement. Okay. First, it sends a sync segment to the receiving host. Then the receiving host sends an acknowledgement, this sync/acknowledgement, to the user. So the receiving host sends acknowledgement ACK segment to acknowledge a successful receipt. Okay, simply user sends a sync request, and this server what it does is it just tells the user that I have received. So it sends another message called sync/ACK. Then again, this user sends another acknowledgement from user to host followed by data, and this process is called three-way handshaking. And this three-way handshaking is only done through connection oriented, that is TCP. In UDP stands for User Datagram Protocol. Okay. What does a UDP packet will have? And a foremost thing is a UCP is a it's a UDP. UDP is a connectionless protocol, and UDP, same like TCP, UDP attaches a header to each packet. The header contains the sending and receiving port, and the field with the length of the packet and a checksum. Then next comes the internet layer, where the packets are prepared for a delivery. A TCP/UDP passes the packet to this layer, and this layer formats. Okay, before that, I'll tell you a small example how you can remember TCP as connection oriented and UDP as connectionless protocol. You can imagine the first UDP as we tie. Those days, people tie a piece of paper in a pigeon's leg and they make it fly, and that will act as a messenger. That is connectionless. So you can remember the oldest UDP for connectionless and TCP as connection oriented. And then next comes the internet layer where packets are prepared for delivery. UCP, sorry, TCP and UDP passes the packets to this layer, and this layer formats the packets into units called IP datagram. This layer determines the IP address of the datagram so that they can transfer effectively. Okay. Now, what is IP datagram and what will it contain? IP attaches the IP header to the segment or packet. In the before layer, we have attached the TCP/UDP packet. In this, we are attaching the IP header. Sorry, not packet, a header to the packet. A segment. IP header includes IP address of sending and receiving host, length of the datagram, and the datagram sequence. Then next comes the data link layer where framing takes place. A data link layer protocol such as PPP, point-to-point protocol, formats IP datagrams into frames. In this layer, the third header is attached called a frame header, and this header contains a cyclic redundancy check, that is CRC. This field checks for error, and the data link layer passes the frames to a physical layer. Physical layer is where frames are sent and received. The physical layers are sends frames over the network medium. This network media will be like optical fiber or coaxial cable. And then, okay, now we have all discussed about how the packet is sent from host to server. Now we'll see how the receiving host or a server handles the packet. Same way, first it will start from the bottom. In the host, it started from the top. It is starting from the bottom. In the bottom, the physical layer receives the packets in frames. The CRC of the packet is computed, and the frames are sent to the data link layer. So, frames sent upward, and the data link layer verifies the CRC of the frame is correct and strips off CRC and a frame header. So what it does is it removes off the CRC header and the frame header, which was attached in the data link layer of the sending host, and then the frames are sent to the internet layer. The internet layer reads the information in the header to identify the transmission. If the transmission is fragmented, if IP resembles a fragment into original data. IP is a short form of the network layer. Okay. IP then strips off the IP headers and passes the datagram to a transport layer. In transport layer, The transport layer reads for the header to determine which application layer protocol must receive the data. Then a TCP/UDP header is stripped off and the message is sent to the receiving protocol. In this, then that will be moved to the application layer, and the application layer receives a message and performs the operation that the host requested for. And a summary of this is: first, the application layer a message to a transport layer, TCP segment into IP datagram, into small frames, then via internet media to again frame. We'll check for CRC and then frame. In data link layer, the frame header will be removed, and then in IP datagram, it will remove the IP header. Then again in TCP, it looks for the message and removes the TCP/UDP header, and then receives a request for login. Here we have given the request for login, and it receives a request for login. We can sorry. First we'll have HTTP, and then we have transport layer, that is TCP. I'll consider TCP here, and then we have IP, then the frame. Okay. Now, first in the application layer, this HTTP request will be sent as a message. Then it will just move on to the transport layer, and in transport layer it attaches a TCP header. Here it will have a HTTP request. Okay. Then again in network layer it attaches a IP header. Then again it is sent to the data link layer, and in data link layer it will have a CRC and a frame header is attached. So totally 3 headers will be attached to the request. Then here then we'll just send it to the server. Just server. I'm using mouse, so it is not convenient to write. Okay, we'll just start as in server. The packets will be received in this format. Now in physical layer the frames will be received and the CRC will be computed. Then this part will be removed. Then again it checks for it goes to IP, or means network layer. Then IP header will be stripped off. Then again it looks for the message in the TCP, so that it can forward the message to the application that requested for the protocol. So then again TCP will be stripped off, and the server will receive the HTTP request. Thank you.